All right, guys, let's get started here. Um, First thing first, I want to give a plan for the next two more classes so you have an idea, okay? I don't like people missing, especially the whole group there is missing. It's not a good thing. December 8th is our last class, and we'll be doing ACT writing plus science test. Sounds good? Okay. Then December 1st, of course, is the Thanksgiving holiday. Gobble. Or whatever. November 24th is next week. I know so Jessica is planning for, I think, English and reading combination. Plus, I'll be doing the math. I actually have to decide based on how you guys do it today. So I'm gonna just keep it as a little question mark here. And of course, today she did the arithmetic and geometry series. Did she start with the trigonometric graphing?
No.
No. Was it, just did the geometric and arithmetic series?
Yes.
That's it. Okay, then I'm actually gonna do science test here and science test here, and today I'll be doing math, then have a few things to cover, okay? And it'll be combination, it's not, maybe I'll do little science passages, it'll be a combination. That's the first thing I want to talk about. Second, December 7th is a review. I know some of you signed up for this one. December 14th, of course, is the D-Day, okay? The big test, okay? Okay. Now, what I want to do today is, today's probably the last day I have where I can answer any questions you have about ACT or anything in general. That's what I did for them, because these 2 days I have a fixed schedule. I cannot mess around with this schedule. So, do you have anything to ask? Yes.
How do you do combinations and permutations?
What's that?
Combinations and permutations.
I'm gonna be actually, I'm gonna show you this, so you think I'm not lying. I'm actually, with the top of my reminder, read that loud.
Collect probability questions.
So I'm collecting some probability questions. You don't have to get into permutations and combinations that big, but I'm trying to do some easy ones at least.
Yeah.
So I was planning to do it, actually, that's what I'm saying. I was planning to do that stuff next, so I'm actually collecting questions.
Okay.
So, but it'll be a combination, so I may do a little science today and little math next week coming. But that's the only thing is left is trigonometric graphing and probability. And I don't want to do anything last day here. Last day is fixed. There's absolutely no room for changing here, but I can change a little bit here and a little bit today. Okay. Good question, thank you. That is something I'm definitely going to be hammering next week, if not today. I may do a couple questions today about probabilities. Anything else? Anything you guys want to ask? Prep, future, ACTs, SATs, anything you want to ask, now is the time.
Can we do like one problem of finding the foci on an ellipse?
Did you do that?
Yeah.
We did that, right?
Yeah.
Yeah. All right, let's do it. Let's get started. See, people usually don't ask me like that, right? And like, that's good for me to know. Like, I can directly get to a specific question then. All right, so let me, give me some time to think about the question. And then you guys can do this, okay? find foci and sketch the ellipse. Okay. Fair enough? No cheating today, no handouts,
Oh, sorry.
no peeking.
Oh,
You guys wanna look at stuff from, okay, cheat, go, cheat. How many got this? Okay, fair enough. Foci, so is it a horizontal ellipse or vertical ellipse? Horizontal, because A is greater than B. So foci is C squared is equal to A squared minus B squared. So it'll be 3 minus 1/3. So it'll be 8 over 3. C is equal to square root of that. Jesus. Is equal to plus or minus square root of 8 over 3. Making sense? How many got this? What? Why? We did this, right? Okay, if you got this step right, how come you guys didn't get this?
I forgot that was already squared.
So you guys took this as square root of this?
I took that squared, so like 9.
Where is 9? There's no 9.
It doesn't say squared, I thought that was just A.
This is a squared.
Well, I know that now.
Am I right? I hope you guys will now understand why I was thinking how to mess you up. And I thought you guys would not fall into this trap. That's why I spent time on what to select here. Come on, guys. Come on. Okay, let's sketch the ellipse. So, what's this center coordinates? Negative 3, 3. Negative 3, 3. How many got this point correct? Should be, right? Okay. So this is a squared, so a is square root of 3, which is 1.732. So somewhere here, somewhere here. So this is the horizontal axis, the major axis. This is 1/3. So square root of 1/3 is what? Square root of 1 divided by 1.73 should be 182. So 0.5 something to that.
577.
Okay. So it'll be 0.57 somewhere here. And somewhere here. So it's a nice little cute ellipse. Right? And what's the foci? Plus or minus of 8/3 from this one, somewhere here and here. Yes or no? John,
Yeah.
fair enough?
Why does the 1/3 go with the Y?
Because this is 1, 3, right? So you have to bring 3 to the bottom. Because x minus x squared divided by a squared plus y minus k squared divided by b squared. So there is no coefficient for this one, so it has to be part. And that's what I was trying to come up with that number. What number would you confuse you guys enough? You fell for it. Cool? Okay. Alright, I have a question of probabilities and stuff like that, so I'm gonna start getting into that one. I'm gonna mix it up today. This was literally a seat of the pants operation. I usually like having a classes planned. But this is fun today, okay? Ready? Okay, this is one question. And if you want something like this, hey, let's do a question on ellipse. I love this, okay? This is fun. All right. I like pizza. Okay? Veggie pizza.
Did you say veggie pizza?
Yeah, I don't eat
That's
meat.
disgusting.
Shit. Okay? So, here's a question, okay? So, I have make my own pizza day, and I have 6 toppings of choice. Okay? Simple, right? Okay. But I'm planning to take only 3 toppings. I have 6 choices, and I want 3 toppings. Okay. How many different combinations of pizza I can have. Get started.
Can you pick three of the same ones?
What's that?
Can you pick three of the same
Okay,
ones?
I was hoping somebody would ask me that question. You cannot have the same topping because it's not going to be 3 toppings at a time. Cheese, cheese, and cheese doesn't make it 3 toppings.
Okay.
Am I making
Uh,
right, Rob?
yeah,
Is
no,
that
yeah.
what you're saying?
Yeah, that was a good statement.
Cheese.
Cheese, cheese, cheese doesn't make it 3.
Three
not-
cheese.
3 cheese topping. No, it's a cheese topping. Maybe deep dish in Chicago. But
Deep dish is good. That's good stuff.
if you have an answer, just call me.
And I bet it's wrong.
The minute you don't think common sense, math fails. That's my only hint for you guys. Okay. Okay.
That might not be right.
I like this one. I don't know the answer, but sounds reasonable at least. Well, he has 2 less than you. I don't know how he got 2 less. Oh, 3 different answers. Well, 3 toppings. Cheese, cheese, and cheese. 4th answer. Domino's is happy. It's a domino effect.
Well, honestly, like, what's your favorite pizza place though?
Jerry's, there's a local place in Sioux City called Jerry's Pizza. That's really, really good. Like,
Papa John's, though, that's good stuff. Papa John's is good
I had a
stuff.
bad experience with them, so I have my
Didn't
reservation.
Papa John's sue Papa John's?
Yes. Then Papa John's left the Papa John's.
Papa John left Papa John's.
And in our language, Papa means sad guy. So they made a lot of fun in our language. Papa means it's like a sad guy. So it turned out that way. All right, I have a question for you guys. Okay. So, and let's use some real examples so it makes sense. So let's say onions, green peppers, and black olives. Okay. So does it matter if I pick onions first, green peppers, and black olives, or black olives first, onions next, and is these 2 same or different?
It's the same.
Same, right? So we have an understanding there. Okay. So let's say if you have 6 toppings, in the first one you can have 6 parts, right? You can pick any of these, right? Then you can have, for second one, 5 different options because you cannot repeat it. Cheese, cheese, and cheese. Okay? And 4. Do you agree? 6 times 5 times 4. How much it is? 120, right? But we just talked about it that OGB and BOG are same, right? So how many we have? 3 toppings, so it's divided by 3 factorial. So 120 divided by 6 is 20.
Good job, John.
So I can have 20 different combinations.
Okay.
How did you do that?
Okay,
Then
could
you
you tell me how you got 6, 5, and 4?
Okay. So how many toppings we have?
Okay, makes sense.
6 toppings, right?
Yeah.
Why is there
So
so
first
many?
topping, I have choice from 6 different toppings.
Mhm.
Once I use it,
But
right?
what's
unlike William, we have to use a different topping.
Mhm.
like what's
And I only have 5 options.
Wow.
put in each?
For the third one, I have 4 options.
Okay.
So it's 120 combination. But as we know, OGB, BOG is going to be the same thing, right?
Yes.
So it's 3 factorial because these 3 toppings in one direction or the other direction is the same.
Okay, so then
3 factorial is 3 times 2 times 1, which is 6.
oh, okay.
Making sense?
Yeah. Can we do another problem like that?
Sure. make sure it's worded correct. Okay, let's say there are 10 prizes. Okay. And I can, hold on, I want to be careful here. No, let's say there are 10 students and there are 3 prizes. Okay? I wanna, hold on, let me do a little math for myself first of all. I wanna be careful how I word this.
Says the guy who says he doesn't need a calculator.
No, I just wanna make sure that my numbers come out. Okay, how many students I said?
10.
Okay.
Yeah.
How many ways the prizes can be distributed? Okay, now,
And it's the same thing, it can't be cheese. One kid
yeah,
can't get all the prizes.
yeah, one kid should not get gold, silver, and bronze. Only Michael Phelps can get it, but the others are humans, so. I get the gold, I get the bronze. Does that make sense now, question?
Can you say,
I just,
can you say all that again?
okay, there are 10 students,
Okay.
and there are 3 prizes. How many ways I can distribute the 3 prizes? Okay, I was making sure the wording was right.
Wait, this is different.
I don't know. I don't like math.
That's interesting.
How many prizes did I say?
3.
3 prizes, 10 students, right? Okay, that's fine. That makes sense. Yeah. Makes sense. Yeah, what do you got?
Want me to say it?
Yeah,
120.
how many you got? 120? Okay, well, seems, no, that's what I was getting, so,
Oh,
So-
so it's right?
I think so.
Okay, great.
So, how many you have? 10, 3 prizes, right?
Mhm.
In the first prize, it can be given to any of the 10 students. Then the second spot will have 9 and 8, right? So 90 times 8 is 720. But if ABC gets the prize, CBA is the same prize, right?
Mhm.
Is it though? Like,
But it's the same, did I say it's a different levels of prizes? And I said price.
oh, so like, if 3 people get prizes, but it doesn't matter which prize they get, as long as they
Get a prize.
Oh,
If it is a gold, silver, bronze, then it completely changes the
It's
problem.
all the same price.
It's all the same price.
so it's just
Like a
just,
coupon.
It's like
It's
three
just
of the same.
it's just gold.
It's a
gold,
coupon.
just gold.
Yeah, yes, gold.
Yeah.
But 3 different people. So 720 divided by 3 factorial is what?
720 divided by 6, which is 120.
120? Yeah, that's where things become interesting. If there are different prices, then it's,
That's what I was.
yeah, that, if it is, so if this guy gets the gold, right, then they have to get the silver, then this has to get, then they'll have 720 combinations.
Yeah.
Because they have more chances, basically. Because now it's a coupon, it's not a prize anymore. So, okay, that's it. Okay, where are they leaving early? Oh, she just left, okay. This is a 7-letter word. Badgers. Okay? You have to make 3-letter words. Okay? 3-letter words. In the first question, the letter can be repeated. In the second question, the letter cannot be repeated. How many combinations you can have?
Do it have to be like real words?
No.
Oh, okay.
Yeah,
I was gonna
it's
say-
not an English test.
Just three letter.
3-letter word,
So
no,
just
sorry. Did I say 3 or 4-letter word?
I think it's a 3.
Oh, it has to be a four, oh, it has to be a 4-letter word.
Well, it doesn't matter. Let's make it 3-letter word.
Okay.
But the only difference is, in the first case, you can repeat the letters. In the second one, you cannot repeat the letters. Go. Yeah, this was not a planned class, by the way. This learning was fun.
No.
What?
75.
I don't know.
Oh, okay. Special, I thought you remember the answer.
Are we adding up the number for each?
I don't know.
What kind of answer are we looking for?
Some number.
One number or two numbers?
2 numbers, 2 questions.
Two different, okay.
Yes. And hopefully they are not the same.
No.
I don't know.
Yeah, the answer calculated already.
Have answers? Yeah.
Permutation and
I'm not getting it. It's not even making sense.
But it's more than the combination.
That's the only good thing so far. Okay, now it's bothering me. Okay, so let's say you can repeat it, right? So you can repeat B, 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 right? So in the first part, you have 7, second spot you have 7, third spot you have 7, right?
Oh, wait, you could repeat the letter? Wait, what?
I said like 4 times, Rob.
Oh, I'm tripping, okay. Oh,
Rob.
What's that? 7 times 7 times 7 is what?
343.
343.
7.
Okay, that's how many times, how many words I can make with a letter being repeated.
Huh.
With a letter not repeating, first spot has 7, second has 6, then has 5. 30 times 210. So, I'm getting 343 and 210.
Why?
This number has to be greater than this, right?
Why? Oh, yeah. But why is there no factorial on the bottom this time for the no repeat?
You can rearrange the letters and words. That'd be why.
Does ARG and GRA same word?
Yeah.
Well,
No,
No, they're not. I'm like, okay, have a good day. That's why.
Okay. So there was no combination, permutation, anything. This is just like
Common sense.
This was fundamental counting principle.
Count, yeah, exactly, it's a counting principle. Here, cheese, green toppings, so green peppers and whatever. So it's the same thing, but here ARG and GRA are 2 different words, not the same one. If they were the same, then divided by 3 factorial, which would be 210 divided by 6 is whatever.
35.
Then you would have got 35.
That I would've got.
Oh, you got, oh, I know why you have 35s now, okay.
Yeah.
I see, okay, well, this was in ACT.
Hmm.
This question, this was in ACT. And actually, you guys would have been lucky because the answer choice did not have 35.
But was it like one of the harder problems, would you say?
It's like question two.
No, not this one. No,
Oh.
I like this one. This was an ACT. Many
Okay.
people wrote 120.
Oh, okay.
Wait, so okay, what is a permutation then? Like, can you, because the pizza one was like a combination.
So,
What's the difference?
do you guys know the definitions of permutations and combinations?
Like, permutation, like order matters, right?
Okay, permutation order matters. Combination order does not matter. So in this case, order does not matter. But here in order matters, ARG and GRAR different. So this is the NPR, this is the NCR. Do you guys like these questions then? Maybe I can think about something else more as well.
I remember there was one on the like October test where it's like, I can't remember the exact numbers, but it's like, say there's 17 total cars in 3 lots, and like a quarter of them are here, a third of them are here, and the rest are here. Like, what are the chances you get 3 from each lot if you pick randomly?
Slow down. What?
So like, I don't remember the exact numbers.
Doesn't matter.
Say it's like
So 3
17
lots?
3 lots,
Okay.
and like a quarter of them are in one. So say it's 17 cars or something. I don't know.
1.
There's a quarter and like a third, and then whatever's left. So it's like they're split into the total amount of cars. So 17 total between the 3.
Oh, total, okay.
And then say there's a quarter in the first one, in the first, a quarter of them in the first
Oh,
lot.
well, it cannot be quarter then, 6, let's go 16.
Oh, yeah, yeah.
Okay, 16, there'll be quarter before.
Yeah,
okay.
and then a third, or, I don't know. But like, you get what I'm saying, like, there's different fractions in,
You gotta figure out a number that's like.
Okay, okay, X over 4, X over 3, okay, tell me.
and I don't know, whatever is left, that would make X. But I'm just, like fundamentally what I'm trying to get at.
Okay, well, I'm still gonna do this, okay. 12x minus 3x minus 4x, so it'll be 5x divided by 3, okay, 5x divided by 12 is here, okay, now what?
So like, so if you pick randomly, what are the chances you get 1 car from each lot?
Well,
That was like number 60.
Oh, yeah.
I guess somehow.
Okay, so was it a number or a variable, first of all?
Hmm?
Was that a number of cars variable?
No, it was all, like they had a total, they gave you a total and they gave you 3 fractions.
Do you know the total number of cars?
Not really.
Okay, so let's pick 60 then, okay? Because 3, 4, and 12 is the least common multiple is 60. 30 doesn't go, 60, okay, 60. So it'll be what, 60 divided by 15 cars here, okay?
Mhm.
And 20 here, and this will be what, 5 times 25 here. All right, okay. They want 1 car from each lot?
Yeah.
What's the probability that if I pick
If you
3
pick
cars?
3 random cars, you get 1 from each.
Okay, 1 divided by 15 plus 1 divided by 20 and 1 divided by 25.
Why is it adding?
No,
up?
hold on. 120, 125, because there is so many cars. So let's say if I have to get all 3 cars from 1 lot, okay? It'll be 3 divided by 15. Let's use common sense. Does the probability be higher or lower of picking 1 car from each?
Higher. It'd be higher than if you get 3 from 1, right?
Yes. To get all 3 will be very, very low probability.
Mhm.
So it will be so there's 60 cars. And we need 3 cars. So probability is basically the events happening divided by the total events, right? What's the total event then? Total number of cars?
3. Oh,
60. Am I right?
yeah.
There's 60 cars. Out of 60, I need to pick 3. Am I right?
Mhm.
But the 3 is not coming from only one, it's coming from individual lots. Let me think about this, okay? I'm not, answer is important, but I'm not, is our process in the right direction? And I don't care what the number they had, basically. This still is a good question to think about, okay? We can make our own question. As I think, I want you guys to try this problem. Go to actually, how many of you have not done trigonometric graphing? Not done? Like, okay.
Is that just like? sign?
Open page 5 of your math packet. You guys can kind of review it, page number 5. I was thinking about this. If I have equal number of cars in each lot, then my chance would be 1/3, right? 33%. Am I right?
Mhm.
one car from each lot, but they have equal number of cars, 20, 20, 20.
So would this be the same?
Well, if you,
So
I mean,
15 and 25,
oh,
average
sure, I
out to
mean,
20?
if you pick three random cars, it could be, I don't know, it could be like the first three in the first lot, it could be the second three in the first lot, or the third three in the first lot.
I don't think that matters.
So they're picking 3 cars total, right? If all the cars were in one lot, what would be the probability?
3 out of 60,
3 out of 60, right?
yeah.
Do you agree with that one? So that'll be 1 over 20. So our probability should be less than 1 over 20 then, because it's gonna be difficult to find one car, because they are separated out. So it'll be a very small chance. Can somebody do this for me? Do you remember the answer choices?
No.
Do 1/15th, do that please. 1/15th times 1/20th times 1/25th
0.000133.
times 100.
0.001 repeating.
Doesn't make sense, right?
Do you have to put in like a divide by 60 or something?
No, that's what I was thinking, that's what I was trying to see. Because divide by 60 won't even matter at the time because it's from each lot. Am I right? The 60 is just to find out how many cars are in each lot itself, right? This 60 is not gonna come into picture at all in the calculation probability because I'm picking one from this. And how many cars we have? 15, right? Out of 15, I need to pick one.
What it
Aren't
makes
you
sense,
picking one from the whole, and you could get one from any lot? You're not just picking a specific car out of one lot.
yeah, you're picking 3 out of 60. And,
You have 60 choices, and you get,
No, but based on his question, you have to pick at least one from each lot.
no, what are the
What are the odds that
chances
you
that
pick
you
one
get
from
one
each
from
lot?
each lot? If you pick totally randomly from out of 60.
Then, what did you got just answer?
0.013 repeating.
Yeah, that would be the answer.
It's just 1/3 times 1/3 times 1/3.
Really?
Or no, not times 1/3.
No, 1/3.
115 times 1.
1/15 times
20.
1/20 times 1. Because the chance would be very, very low. Now it's, because if you pick 3 cars, the chances it's coming from this are higher. Am I right? But if you have to pick from each one, at least one, this will be the toughest one because it have 1 over 25 then. Oh, I need to think about this. I wish I had the questions now, it's gonna bother me. Do this for me, please. 0.25 times 1/3 times 25 over 60. What do you got?
0.347. 0.0347.
Okay. 1034, right? Times 100,
3.47.
that's my answer. 3.5%. I wish you had the answers, man, this is gonna bother me now. I'm pretty darn close, I'm pretty damn confident this is right. Here's what the logic is. I'm trying to understand this question first of all before, my rule is this, if I don't know the question, my answer is usually not right. So, there are 60 cars, and I want to pick, and there are 3 different lots. What are the chances that each car I'm gonna pick are from different lots? Am I right?
Yes,
Okay, so it has to be a very small percent,
yeah.
okay? So, for the first lot, okay, a 15 by 60 chance of picking that one car, okay? Second one is 20 out of 60, and then it'll be 25 out of 60. This is my answer.
Wouldn't it be 20 over 59? And 25 over 58?
You're right, because once I take the car, the
Yeah.
number of cars.
So it's 3.
No, hold on. Am I picking them one after another?
You're picking 3 random cars, but yeah, you can't pick them all at once. Well,
Is it like all 3 at the same time? Because the question is, I need 3 cars, I'm picking 3 cars
yes.
at the same time, but they should be different lots. So each lot has, out of the possible 60, right? Is it one, okay, I pick one, oh, lot 1, is it done? So I'm gonna go to lot 2, and then lot 3? Is it like one topping, then second topping, then third topping?
I feel like you have like all of the cars in a hat.
And I pick 3 at the same time, 3 cards.
That wouldn't change your odds though, would it?
It does, because you want the chances, you want those 3 cards coming from 3 different lots, not from the one lot. I know what you're saying, 59 and 58 here, right? But you're saying that one car after another then.
Yeah.
I don't know. Of course, we don't have the question completely, we don't have the answer, but my guess would be 3.5%. Seems very reasonable, but at the same time, it's gonna be very low chance of getting it. Because why? There are more chance of getting it from these 2 than this one.
Yeah.
Am I right? Because this is only 15. But if you have to get it from all 3, the permutation, the probability is just gonna nosedive. I don't think so it's gonna be 59 and 58, because you're not, what makes you think it's 59, 58? I'll tell you. So that means the second choice you're picking, you already know which lot you picked the first car from then.
Yes.
No, are you sure? It just means that you know you picked
It means that you picked one.
One already, right?
Yeah, but you don't know which lot it came from.
And
Okay.
you can rearrange the denominators, and I think it still works.
It works
So it
then.
doesn't matter, so that wouldn't matter.
Does it say, was it all 3 picked at the same time, or one after another?
I honestly don't think they specified, like, I think it said like pick 3, what are the chances they pick 3 cars from different lots? All from different lots.
Get a calculator, get a calculator. Do 15 times 20 times 25. Okay, divide by, in parentheses, 60 times 59 times 58. I know what you're saying, I absolutely know what you're saying.
And that gives you 3.6%.
Of course, you'll have a higher probability, because you know the first lot,
Yeah, 'cause
you know
it's-
the probability because your number of cars are reducing, so your chances are higher.
Yeah.
Like by like just,
0.2%, 0.25%, that was my expectation, was to increase by slightly. Damn it, now you're gonna bother me now, thanks.
Hey,
Okay, all I'm wondering though is like, who came up with this problem, honestly?
No, this is a reasonable question.
Yeah, I know, but like, I don't, like, just like imagine like coming up with all these, honestly.
Well, I did for Powerball. That's, I know now why I don't win it. Simple.